HA7062C and HA7062D phase noise analyzers are able to perform a number of different measurements, which allow engineers to be able to measure the phase noise of the entire system with an absolute measurement, or from one component of the system with an additive measurement. Today I'll be covering how to measure the phase noise from an individual component of the system that does not natively create an RF signal. Here I have my HA7062D phase noise analyzer, and I'm going to show you how I've got it configured for an additive measurement. In order to do that, I'm going to walk you through what we're testing and then how we're testing it, and that'll explain our whole configuration here. So to start off with, what we want to do is we want to find the phase noise that's generated by the HX2600 RF amplifier, which we sell. And we want to find out just the phase noise from this device itself. It does not create its own signal, it's just amplifying the signal that's coming in. So in order to do that, there's a couple things. So first we're going to power our amplifier with our power supply port, which I can configure within the GUI, and I'll show you that in a minute. But then the output's going to our DUT input, and our input's coming in and coming from this 1 to 3 power splitter. And I'll get more to that in a minute. I've also got the jumper cables connected here on the front of the unit from our DUT channel 1 input to our DUT input, along with channel 2 as well. Now back to the 1 to 3 power splitter. This 1 to 3 power splitter is taking a signal from a signal generator, specifically a 100 megahertz signal. It's coming in and splitting it 3 ways. One way is going to our RF amplifier, and then each one of the channels is getting its own signal itself. Then it's being passed through phase shifters, specifically the HX5100s, which we sell and makes additive measurements a lot easier. That is then phase shifting that signal for cross correlation within the unit. And what this will allow us to do is, since we're not using the LO built into the phase noise analyzer, but instead using the signal generator as the LO, we will be able to use cross correlation to then remove the signal generator's phase noise, which is coming through this power splitter. And we will only be left with the phase noise that's being generated by our amplifier itself. In order to configure the software to be able to put the instrument into an additive measurement step, first I've gone ahead, I've already opened it, and I've already connected to my phase noise analyzer under the devices menu. Now, in order to put the instrument into an additive measurement, we need to go into measurements. And then within here, we need to go to the measurement type. Currently it's set to absolute. We need to change that to additive. Then data type, we want it to be cross correlation because we are looking for the instrument to remove the phase noise that's generated by the signal generator. Then the IF gain, we're going to leave as auto. Trigger type, single. Data resolution, we'll leave it at the 256 standard. Number of correlations, let's change this over to 5, just because I want to have a couple more correlations. Now, the next thing we need to do is we need to power the amplifier itself. The phase shifters will basically take their tune voltage. The software is going to control that for us, but we need to power the amplifier. So let's go into outputs, and then the power supply for it is controlled through the DUT supply output. So I'm just going to take this and increase it up to, looks like 12 volts, right like that. Current's going to be just fine for this. And then from there, we're now powering the amplifier. So basically the 100 megahertz signal that's coming in is now being amplified into the DUT input, along with being split to our 2 channels. Next, let's go talk about inputs. So a couple things to note within this menu. So for additive measurements, this is specifically for additive, we have the choice between the HX5100s, which are the electronic phase shifters that I currently have configured and connected to my phase noise analyzer. And we also have mechanical. Mechanical phase shifters are great. They're just not automated through our system, but we can use them for additive measurements. Let's change this back to HX5100s because that's what we're using. And then from here at this point, I'm going to hit acquire. It's going to take a few seconds. We'll see that in the lower right-hand corner, and they'll propagate on the display. So let's make this display a lot easier, and let's note a couple things. So this is currently showing the phase noise captured from just our amplifier itself. And then essentially what's happening is we've got relatively flat phase noise from our close-in phase noise all the way to our further out phase noise, which is at basically the instrument's limit due to our current carrier frequency range. It is automatically limiting it. So we have relatively flat phase noise, which is great to see on these amplifiers. We've got down right below it, we've got our trace type. So this is just the name of the trace. I can go in and change this if I would like to. Our measurement type, time it took to take the measurement, it took 1.3 seconds to do all 5 correlations. Our DUT input frequency, this is great to keep an eye on and check, just because in case something happens and you're running tests, it's a good place to start. Just confirm that your DUT input's correct. It's working with your electronic phase shifters along with the specified range for your device under test. And then our DUT power. I don't want to exceed 20 dBm. Currently I'm on the top end of this because I'm splitting the power between our 2 LO channels along with the DUT input. It's registering pretty high. So that's pretty much how to make an additive measurement. If you run into a couple issues with the software, say channel 1 or channel 2 aren't connecting right away, it's always good to double check connections, but also it may require you increasing the power output of the signal generator itself in order to get the LOs enough power, because you are splitting the power down. The HA7062C and the HA7062D are great phase noise analyzers for performing additive and absolute measurements. In this demonstration, we covered how to configure the instrument along with the extra components that are needed for performing additive measurements, which allow engineers to not only debug the entire system phase noise, but now with additive measurements, able to debug individual components phase noise and how they're contributing to the overall device.